Hello, we're going to take a chance now to take a look at standard forms of quadratic equations or parabolas, and we're going to turn them into factored form. There are some situations where factoring is easy and some situations where factoring is difficult. The situations where factoring is difficult typically is when we have a number that is multiplying onto the x squared part of our quadratic function, or also known as a parabola. So we're going to look at an example and we're going to go through the procedure for factoring this sort of expression. And that way, if we're looking at the equation of a parabola or the graph of a parabola, we can use this factored version in order to find the x-intercepts. And that's equivalent to solving a quadratic equation. So let's take a look at that now. So I have here on the screen an equation of what would be a parabola if we graphed it. This is a quadratic function. It's quadratic because we have a part of it that says x squared and another part that has just x in it. Our goal here is to put this standard form equation of a parabola into factored form, and we're going to use that to find x-intercepts. So what we're going to do in order to factor this, and because we're anticipating this is going to be a little tricky to factor because of this number here that's multiplying onto the x squared, what we're going to first do is identify our three key numbers that are in this function. These three numbers are called coefficients, and typically they have the names A, B, and C. Our very first step is we're going to take A and C, and we're going to multiply those two numbers together. If we multiply those two numbers together, we're going to get A times C. That's going to be 2 times negative 15. You got to remember that negative there. That's going to give us negative 30. Then our next step, once we've computed A times C, is we're going to do the following. We're going to find two numbers that multiply to give you AC, but add together to give you B. In our case here, B is negative 7. So what we're looking for is we're looking for two numbers. Those two numbers are going to multiply to negative 30, and they're going to add to negative 7. So we kind of need to think a little bit, what numbers are going to multiply to negative 30 and add to negative 7? This is the part where it can be a little tricky, and there isn't really any kind of shortcut I can give you. However, I recommend first thinking about what numbers could multiply to negative 30, and then from there, check some of the pairs to see if you can find two that add to negative 7. Take a moment to think about that now. Pause the video in order to actually think about it, because this practice will make these questions easier in the future. So think about that now. The two numbers that are going to work in this case, that are going to multiply to negative 30 and add to negative 7, these two numbers are going to be negative 10 and 3. Negative 10 times 3, that's negative 30. Negative 10 plus 3, that's negative 7. So what we're going to do with those two numbers now is we're going to take the portion of the equation that had the b in it, the bx part, and we're going to split up that bx into two pieces. So I'm going to keep the ax squared, that's the 2x squared. I'm going to take the bx and I'm going to split it up into two pieces according to these two numbers that I found here, the negative 10 and the 3. So we're going to do minus 10x plus 3x, and then I'm going to keep the c, that's going to be minus 15. At this point, we're going to be doing a procedure called factoring by grouping. Factoring by grouping means that we're going to group up the first two terms, and then we're going to group up the second two terms. When we factor by grouping, we're going to think about trying to find the greatest common factor of the terms in each group. So let's first look at the group on the left. We have 2x squared minus 10x. What's the greatest common factor of 2x squared minus 10x? Take a moment to pause if you need. The greatest common factor of 2x squared and minus 10x That's going to be minus 2x. I'm sorry, not minus, just 2x, 2x. 2x divides into 2x squared, and 2x divides into negative 10x. So what we're going to do is we're going to write that GCF, 2x, and then some parentheses. We then need to think about, if this were a distribution problem, what numbers would I be distributing that 2x onto to get that original thing I started with? So think a little bit. 2x times what would give us our 2x squared? 2x times what would give us our 2x squared? That's simply x. Now think, 2x times what would give us negative 10x? 2x times what would give us negative 10x? That's going to be negative 5. So we have now factored that piece. Next, we identify the GCF for the next part. We have 3x and negative 15. What's the GCF? The greatest common factor? That's 3. So I'm going to write the GCF out here, the greatest common factor, and think, okay, 3 times what gives us 3x? It's simply x. 3 times what gives us negative 15? It's negative 5. The magic of the technique that we did up here, the magic of that technique is that whatever we get in these parentheses will always match. If they don't match, we did something wrong. They do match though, so now we can continue a little bit and factor even further. So I'm going to move this now up here. We should have a y here as well. So I'm just going to recopy this down. Y equals 2x, parentheses, x minus 5, plus 3, parentheses, x minus 5. We're going to factor this again because now we have a greatest common factor. The greatest common factor of these two terms, the term on the left and the term on the right, the GCF, is now the x minus 5. So I can think, all right, if I have x minus 5 over here, what would this have had to have multiplied to get this part? Well, we can see it right there. The x minus 5 multiplied onto 2x. I'm going to write another y here as well. Then similarly over here we look, what needs to be multiplied over here? Well, that's just a 3. So we do plus 3. Once we've done this, this is technically factored. We are now fully factored. There is one additional step that we can do to go just a little bit further. What we're going to do, just to go a little bit further here, not necessarily required, but I'd like to do this for completeness, is we're going to take this 2 that's out here, this number that's multiplied onto the x, and we're going to factor that out as well. So we're going to pull out the 2. That x minus 5, that stays the same over here. And we're going to think, okay, 2 times what? And 2 times what would have given us 2x plus 3? Well, to get 2x, we would do 2 times x. Then 2 times something is going to give us 3. 2 times 3 halves gives us 3. Now this here, this is what I would consider 100% fully factored. So this here, this is our complete answer, totally fully factored. Some teachers, though, don't really care much about that last step. So the previous line, that's also okay as well. It just depends on the standards of your teacher. However, what I do like about that last form, if we're looking at the equation of a parabola, which will be something like this, a times x minus r1 times x minus r2. If you are able to get that value of a out here, which is always the same as the value of a in the original equation, if you can get that value of a out there so that you just have x and x without anything multiplying on those x's, those two values of r, these are what in math we call roots. They're sometimes called roots. They're sometimes called zeros. but they're best known as x-intercepts. They're just three different names for the same thing. I don't know why we have three names for them, but we do have three names for them. They are the x-intercepts. But because in this formula we have minus signs already implied in there, when we look at our original formula up here that we computed, we just need to remember to flip the sign. So what that means is that when we look at this and we think, okay, what x-intercept does that correspond to? That's the x-intercept of -3/2. And what x-intercept does that correspond to? That corresponds to +5. But those are our x-intercepts of that function. So let's go ahead and look at Desmos now. I'm going to go ahead and plug in the original equation that we had, y equals 2x squared minus 7x minus 15. Here's our parabola. I'm also going to go ahead and type in the version that we got, our factored form. We should find that that's exactly the same because it's just another form describing the same parabola. It overlaps. It's the same thing. So we have two roots, two x-intercepts, two zeros, the same thing. Negative 1.5, that is -3/2. And then we also have 5. That's also what we got as well. So this matches up. This represents our x-intercepts. This is an example of taking a parabola, an equation, y equals something, something, something with x's, and then from there, figuring out the end results in a factored form. From the factored form, we can then determine the x-intercepts of the function. Another very similar situation where you might encounter basically exactly the same procedure is where you have to solve something like this. You might have an equation that says solve for x. And your equation is going to be the same as what we have here. So why don't I just copy that down here? It's going to be the same, except instead of having a y, you might have a 0. This is what's called a quadratic equation. And from a mathematical point of view, solving for x here is exactly the same problem as finding the x-intercepts. So if you could follow those steps that I used to find the x-intercepts, you can also solve exactly this equation. You would follow exactly the same steps as before. And as a result, what you would find is 0 equals 2 times x plus 3/2, parentheses, x minus 5. That would be your result. You'd use exactly the same procedure. You'd get that same result on the right-hand side. This is the factored version. So this is fully factored. Then remembering the zero product property, we can remember that whenever we have two numbers multiplying to give you 0, this implies that either A or B equals 0. So that means, this is going to look very familiar, this part here, x plus 3/2 equals 0, or x minus 5 equals 0. Solving for x in each case gives us x is equal to -3/2 and x is equal to 5. Those are the two solutions that work in the original quadratic equation. And those answers we got are exactly the same as the x-intercepts we got when we were looking at it in a y equals context, in a graphing context. Both of those problems, they're exactly the same problem, just phrased in different ways. Finding the x-intercepts of a parabola is the same thing as solving for x in a quadratic equation where you have 0 set on one side. They're the same thing mathematically, and they always have the same answers. And you can use the same method for both of them. So both of those kinds of equations, or both of those kinds of problems, they're basically the same thing, and they have the same sort of solution procedure. So I hope this was helpful for clearing up this procedure. It is a little bit of a tricky procedure to get the hang of, but I hope seeing it in a video here like this can help you replicate it in the future. So thanks for taking the time to watch. And if you have any questions, feel free to reach out and I can give you some help.